Let's take a look at this example. Okay, please notice that in this circuit we have over here negative voltage. What does it mean? It means that my power supply is connected to the circuit in this way. Okay, it means that the positive terminal is connected to the ground and negative terminal is connected to our resistor R3 and our resistor R2 from the top. Okay, so the current in this circuit, of course we are using the conventional current flow, is going to flow this way. This is going to be my I total, and this is going to be my IR1, this is going to be my IR2, sorry, this is my IR3, and this is going to be my IR1. Okay, this is my R1, R2, R3. What we're supposed to find? We're supposed to find R1. In order to find R1, we're supposed to have two pieces of information. Please notice that we have parallel circuit. In parallel circuit, the voltage across each component is the same. So it means that V1, which is my voltage source, is equal, this is my V1, is equal to VR1, this is also equal to VR2, and this is also equal to VR3, okay, and this is equal negative 16 volts. Okay, now because in this circuit current is going to go from the ground, right, from the ground up, okay, it's going to go in opposite direction that we used to have, so we're going to say that the current is negative, okay, because current is going to go this way. Okay, so we are going to say that my IR1, okay, this is my IR1, is equal negative, okay, 0.073 amps is equal to 73 milliamps. Okay, so this is negative 73 milliamps. Now, if I have the current which goes through resistor R1 and I have voltage across resistor R1, I can find the resistance R1 using Ohm's law. R1 is equal VR1 over IR1, where VR1 is equal negative 16 volts over current, which is equal negative 73 milliamps. Okay, so this is my resistance. Now negative and negative will cancel out. Keep in mind that if your resistance is going to come out negative, means you are doing something bad. Okay, so there is something wrong, so make sure that you are going to look at your signs, and we have 16 divided by 73 exponent 3 negative. This is equal 219.17, so I have 219.17 ohms. Okay, my resistance is positive, so everything looks fine. So this is approximately 220 ohms. Okay, this is the value of resistor R1. Next, I'm supposed to find the resistor R2, resistance of resistor R2. So what I have to do, I have to find the current first, current which will go through this resistor. Please notice that this current, this one, is the sum of these two currents. So I can write that I12, okay, I mean the sum of these two currents is simply IR1 plus IR2. Okay, and don't forget that we are dealing with the negative values of the current, so we are going to have later on negative signs So, but let's solve this formula first for IR2. So what I'm going to do, I'm going to move it to the left side, and I'm going to have something like this. I12, or I can say IR12 is the same thing in this case, and this is going to, we're going to subtract from it IR1, okay, and this is going to give me IR2. Okay, so I have IR2 is equal, and in this case I have IR12, which is equal 114 milliamps, but it's negative 114 milliamps because its current is going to the voltage source, okay, to the negative terminal. So minus, okay, and I have negative, because this is also negative current, 73 milliamps. So this is equal, okay, you can use the calculator. So I have negative 114 exponent 3 negative minus negative 73 exponent 3 negative. This is equal negative 41 milliamps. So this is my IR2, negative 41 milliamps. Okay. Now we can find the resistance R2. R2 is equal VR2 over IR2. VR2 is equal negative 16 volts over negative 41 milliamps. Okay, so this is equal. Keep in mind that negative and negative will cancel out, and resistance must be always positive. So I have 16 divided by 41 exponent 3 negative. This is equal 390.24. 390.24 ohms. Which you can say this is approximately 390 ohms. Okay, so this is the value of my resistor R2. Next, I'm supposed to find P2, okay, because I have current which goes through resistor R2, and I have voltage across resistor R2. I can find power very easy. P2 is equal IR2 times VR2, and this is equal, IR2 is simply negative 41 milliamps times VR2, which is equal negative 16 volts. This is equal 41 negative exponent 3 negative times 16 negative is equal 656 milliwatts. In order to find the total current, okay, we're supposed to find the current which goes through resistor R3. So we simply write that IR3 is equal VR3 over R3. VR3 is equal negative 16 volts over R3, which is equal 510 ohms. So this is equal 16 divided by, of course, negative 510 equals, this is going to be negative 31.37, negative 31.37 milliamps. Okay, so if we want to find I total, simply write I total is equal the sum of these two currents, I12 plus IR3. So I write IR12 plus IR3. IR12 is given and is negative 114 milliamps plus IR3 negative 31.37 milliamps. So this is equal. We have 114 negative exponent 3 negative plus negative 31.37 exponent 3 negative equals negative 145.37 milliamps. Okay, so let's check what we have found. We have I total. Okay, we found R1. Okay, we found R1. We found R2. We found P2. So we can say that the problem is solved.